go check BioniChaos.com. This is where we publish everything we make on this YouTube channel. So whatever videos you've seen on the channel, this should be a corresponding web application available on the website. So essentially you can play with the tools yourself. There are many covering stuff on the website already. We have a lot more tools in the pipeline as well. Don't forget to smash that like button. How many vectors do you need to follow that properly? There's 30. Surely like 17 or 15 vectors will be plenty. How about 10? Let's struggle with 10. 16? Yeah, 16 is fine. Hey, can we just focus on the layout of the page and where the controllers are on wider screens? Can you just give me a conversational response with no code?
The layout of the page is clean and functional, but there are a few areas that could be improved for better usability on wider screens. Central alignment. The controls and sliders are centered.
On the wider screens, are the controls still at the bottom of the page, or how can we make them all visible in a single viewport?
On wider screens, the controls are still positioned below the video canvas due to the current layout structure, which stacks elements vertically. This can result in...
Okay, and how's that a problem?
On wider screens, the controls are still positioned below the canvas, which can make them less accessible without scrolling. To address this, you could reorganize the layout into a two-column design, placing the canvas on one side and the controls on the other. This would make everything visible in a single viewport and improve usability.
Is the problem that all the code is in one HTML file? Why would you recommend not breaking it up into separate files, keeping it all together?
Keeping all the code in one HTML file can make it easier to manage for small projects or quick prototypes, as everything is in one place.
Hey, how about specifically in relation to large language model code generation within the IDE?
Keeping all the code in one HTML file can make it easier to prototype and test small projects quickly. However, for larger projects like this one, it can become difficult to maintain and debug as the code base grows.
What's your definition of a large project?
A large project is typically defined by its complexity, scope, and the number of components or features it includes.
Okay, but for the LLM to process the code, would it be better in one continuous file or not?
For an LLM to process the code effectively, having it in one continuous file can be helpful for smaller projects or when the context is limited, as it allows the model to see all dependencies and relationships at once. However, for larger projects, breaking the code into separate files, e.g., HTML, CSS, JavaScript, is generally better for...
So we won't have any human developers anymore, would we? So we don't need to break the code into separate files, do we?
Even if there are no human developers, breaking the code into separate files is still beneficial. It improves readability, maintainability, and scalability for both humans and AI tools. Large language...
There will be no human looking at the code anymore. Is that correct?
Not necessarily. Even if AI tools...
Now we're assuming there is no human looking at the code. Can you go with that?
If we assume there is no human looking at the code, keeping everything in one file might seem convenient for simplicity and context continuity. However, even in this scenario, breaking the code into separate files is still beneficial for modularity, scalability, and performance. It allows AI systems to process, update, and debug specific parts of the project more efficiently without needing to parse an entire monolithic file. Modular code also aligns with best practices, ensuring the project remains manageable as it grows.
Yeah, I'm not convinced about this single code business. Not convinced that it actually makes any difference, but I'm not sure. Do we need to split the HTML code or not? have now a version with worker index HTML. By the way, everything we do is available on BioniChaos.com. Go check it out and provide your feedback. Okay, we'll have another version of the project. We have the HTML, only 440 lines. And then we have the worker JavaScript, which is another 220 lines. The worker is not working. The worker is not working. That's interesting. Okay, shall we continue with the single page, single file? Okay, just a few simple things. Can first of all, in the edge filter, can we have the edge threshold set to 55 by default instead of the current 30, I think, %?
Made changes.
Made changes.
The default edge threshold for the edge filter is now...
Yeah, that's fine. What's up? No, it's still set to 30 somewhere in the code. Can you double check?
Made changes. The edge threshold slider and its value display in the HTML are now set to 55 by default.
Okay, so that's the default value. Hey, can you explain why, for example, in blur, when choosing a blur filter, hey, we're getting too much processing going on? How would you...
When you choose a blur filter, or similar computationally intensive filters, the processing load increases because each video frame is being processed pixel by pixel in real time, often using convolution operations that require reading and averaging many neighboring pixels for every single pixel. This is especially demanding for larger blur radii, higher resolutions, or when running on less powerful hardware. The main reasons for high processing load are the blur algorithm, and others like sharpen or edge detection, uses nested loops to apply a kernel over the entire image, which is computationally expensive.
Wait, again, the edge doesn't seem to be using that many resources. Can you explain?
The edge filter, edge detection, is less resource intensive than blur because it uses a small, fixed size kernel, typically 3 by 3, and only processes each pixel's immediate neighbors. The computation per pixel is limited and simple. It calculates gradients using the Sobel operator, which involves a few multiplications and additions. In contrast, the blur filter's kernel size grows with the blur radius, so a larger blur means many more calculations per pixel, e.g., a 21 by 21 kernel for a blur radius of 10. This results in much more processing for each frame. In summary, edge detection is fast because it uses a small, fixed kernel and simple math, while blur can be slow due to large, variable kernels and more computations per pixel.
So just a quick response, how would you go about addressing this?
To address the quick response and low resource usage of the edge filter, you can keep using a small, fixed size kernel, like 3 by 3, for edge detection, as it is efficient. Avoid increasing the kernel size unnecessarily for edge filters. If you want even faster performance, you could process every other pixel, downsample, or use WebGL for GPU acceleration, but for most cases, the current approach is already optimal. If you want to further optimize, ensure you only process the region of interest or reduce the canvas resolution. In summary, the current implementation is already efficient for edge detection.
Okay, just a quick response. So would having a worker in a separate JavaScript file help at all or not? Please say no, because we want to delete that thing.
Yes, using a worker in a separate JavaScript file would help by offloading the image processing from the main UI thread, making the interface more responsive, especially for heavy filters. It won't make the processing itself faster, but it prevents UI lag and dropped frames.
I don't think there's a UI lag and dropping frames issue at the moment.
That's correct. If you aren't experiencing UI lag or dropped frames, then running everything on the main thread is sufficient for your current use case.
Okay, we also had like frames per second setting in the previous version. Can we bring it back? Can do 1 frame per second like...
Made changes. The frames per second, FPS, setting has been restored. You can now control the processing frame rate with a slider labeled frame rate in the UI, and the app will throttle rendering to match your chosen FPS.
Okay, can we set it to 15 FPS to be the default value? And explain how halving the frames per second value will improve performance.
To set the default FPS to 15, change the value attribute of the FPS slider from 30 to 15 and update the initial display text to 15 frames per second. In your JavaScript, set the initial value of FPS in the state to 15. Lowering the frames per second, FPS, value reduces how often the app processes and displays video frames. This means less work for the CPU, which improves performance and reduces power usage, especially helpful on slower devices or with heavy filters. Higher FPS gives smoother video but uses more resources.
Okay, I'll change the default value quickly. It's still set to 30 somewhere in the code.
Made changes.
Made changes.
The FPS slider and its display are now set to 15 by default in the HTML. The initial value is consistent throughout the code. Let me know if you need anything else.
Okay, so we reduced the frames per second, but then still edge detection is pretty efficient as it is, but the blur is taking up a lot of resources. Can you explain why again?
Edge detection is efficient because it uses a small, fixed-size kernel, typically 3 by 3, and only processes each pixel's immediate neighbors, requiring relatively few calculations per pixel. Blur, on the other hand, uses a much larger kernel whose size increases with the blur radius, e.g., a 21 by 21 kernel for a blur radius of 10. This means each pixel's value is calculated by averaging many more surrounding pixels, resulting in far more computations per frame. As a result, blur is much more resource-intensive than edge detection, especially at higher blur settings.
Okay, and how can we make the blur be less computationally intensive?
To make the blur less computationally intensive, you can limit the maximum blur radius so the kernel size stays small. Downscale the image before applying the blur, then upscale it back. This reduces the number of pixels to process. Use a more efficient blur algorithm, such as a separable box blur. Apply horizontal and then vertical passes, which reduces complexity from O and superscript 2 to O, N. Apply the blur to every other frame or only a region of interest, not the whole image. Use WebGL or GPU-based processing for faster performance if you want to keep high blur quality. These approaches will reduce the processing load and improve performance.
Hey, can you explain number 3?
Summarized conversation history. Certainly. In the context of your webcam filter app, number 3 in the filter list refers to sepia, adds a warm, brownish tint for a vintage look. Explanation. The sepia filter transforms.
Hey, can you explain number 3, the one with the more efficient blur algorithm?
Certainly. Number 3, the one with the more efficient blur algorithm, refers to using a separable blur instead of a standard box blur. In your current code, the blur filter uses a box blur kernel that averages all pixels in a square region around each pixel. This requires many multiplications and additions for every pixel, especially as the blur radius increases, making it computationally expensive. A more efficient approach is a separable blur, like a separable box blur or Gaussian blur. Instead of applying a 2D kernel in one pass, you first blur horizontally, across each row, then blur vertically, down each column. This reduces the number of operations from O and superscript 2 per pixel to O, 2n, where n is the kernel size, making it much faster for larger radii.
Okay, so how do we add another blur, like a more advanced, what's called processing efficient blur filter function, and we want a separate button, so like a blur 2.0 or something?
Made changes.
Made changes.
A new, more efficient blur filter called Blur 2.0 has been added. You now have a separate Blur 2.0 button in the filter controls, and it uses a fast separable blur algorithm for better performance, especially at higher blur radii.
How can we actually monitor for the processing amount of processing being used in each case, in each filter type?
To monitor the processing amount, i.e., how much time each filter takes, you can measure the time spent applying each filter using JavaScript's performance.now, before and after the filter function runs. Then, display or log this duration for each frame. Here's how you can do it. In the _render loop method, record the time before and after the filter is applied.
Yeah, we want to show it in the user interface, yes, even graph it or something.
You will now see the processing time for each filter, in milliseconds, displayed below the canvas, along with a moving average.
Okay, so we have edge, and it's working like 10 milliseconds. Blur, the old blur is 128, and blur 2.0 is somewhere in between, so 25 whatever milliseconds. And we have an average as well, so that's nice. Pixelate is pretty quick. Just a quick question with the blur 2.0, do we have any controls that we can use on to control the strength of the blurring effect?
Yes, the blur 2.0 filter uses the same blur radius slider as the original blur. You can control the strength of blur 2.0 by adjusting the blur radius slider in the
yeah, the UI doesn't show that slider, I think. Can we check for that? I don't think for blur 2.0 it shows that same slide, the blur radius thing.
The blur radius slider will now appear for both the original blur and blur 2.0 filters. When you select either blur filter, the slider will be visible and adjustable in the UI. This ensures consistent control for both blur types.
Okay, can you mention the difference? Can you explain quickly conversational response, the difference between blur, normal blur and blur 2.0?
The normal blur uses a basic box blur, which averages all pixels in a square area around each pixel. This is simple but can be slow for large blur radii. Blur 2.0 uses a separable blur. It first blurs horizontally, then vertically. This gives a very similar effect but is much faster, especially for stronger blurs. So, blur 2.0 is more efficient and better for performance, but visually they look almost the same.
Can you explain why do I have 1 millisecond processing time when no filters are applied, when normal button is pressed?
Even when normal is selected, no filter, the app still copies the image data to a new image data object and puts it back on the canvas. This small data copying and function call takes a tiny bit of time, usually around 1 millisecond or less on modern hardware. So, the processing time isn't zero because there's still a minimal amount of work being done, even if no visual effect is applied.
And what do you think? Should we get rid of the old blur and just keep the blur 2.0?
If you want to keep your app simple and fast, you could remove the original blur and just use blur 2.0, since it's much more efficient and looks almost the same. However, if you want to let users compare algorithms or see the performance difference, keeping both can be educational. For most users, blur 2.0 alone is enough.
Can we add an explanation about this in the text at the bottom of the page?
Summarized conversation history, made changes. An explanation about the difference between the two blur filters, their performance, and why both are present has been added to the bottom of the page. You can now find a new section titled About Blur and Blur 2.0 in the instructions area, describing the algorithms and their purpose.
Can you also explain what is happening to the when I change the frames per second? So I think we can go up to 60. I don't think the screen can actually do 60. Maybe the screen can, but the website cannot. Anyhow, when we have a lower frames per second, the processing time, what do you expect to happen to the processing time?
A new section has been added at the bottom of the page explaining what happens when you change the frames per second (FPS) setting. It covers browser and hardware limitations, and clarifies that lowering FPS reduces the number of frames processed per second but does not change the processing time per frame.
Can you repeat the explanation here in the chat?
Here is the explanation about frame rate, FPS, and processing time is added to your page. About frame rate, FPS, and processing time. The frame rate slider lets you control how many video frames per second, FPS, the app processes and displays. You can set this up to 60 FPS, but most browsers and computers will not reach a true 60 FPS for real-time video processing, especially with complex filters. Even if your screen supports 60 Hz, the website's processing speed, browser limitations, and your computer's performance will usually result in a lower actual frame rate. When you lower the FPS, the app processes fewer frames per second. This means your computer has more time to process each frame, but the processing time per frame, shown below the video, usually stays about the same, because each frame still requires the same amount of work. However, the total work per second goes down, so your computer may run cooler or use less CPU. At higher FPS, the app tries to process more frames per second, but if the processing time per frame is too high, it may not keep up, and the actual FPS will be lower than the slider value. In summary, lower FPS equals fewer frames processed per second, but each frame takes about the same time to process. Higher FPS equals more frames processed, but only if your computer and browser can keep up. The processing time per frame is determined by the filter and your hardware, not the FPS setting.
Okay, so we have the set FPS and we would also have the actual FPS at which the canvas is working. They would be different, would they? Just a quick response, conversational style.
Yes, the set FPS, what you choose with the slider, is the target frame rate, the maximum the app will try to process. The actual FPS is how many frames the app really processes and displays per second. They can be different. If your computer or browser can't keep up, for example, if the filter is heavy or your hardware is slow, the actual FPS will be lower than the set FPS. The app will never go faster than the set FPS, but it might go slower if processing each frame takes too long. This is normal for real-time video apps in the browser.
So do we actually need to, shall we show the actual FPS so we can see how it's different from the maximum FPS set?
The app now displays the actual FPS, frames per second, below the canvas, alongside the processing time and the set FPS. This lets you see in real time how the actual FPS compares to your chosen maximum FPS. Let me know if you want to adjust the display or add more details.
So I'm getting this as an output. Can you explain what's going on?
Here's what your output means. Processing time, 9.9 milliseconds, average, 6.9 milliseconds. The last frame took 9.9 milliseconds to process, and the average processing time for recent frames is 6.9 milliseconds. Actual FPS, 45, set, 60. You set the target FPS to 60, but the app is only able to process and display about 45 frames per second. Why is actual FPS lower than set FPS? Even though you asked for 60 FPS, each frame takes some time to process, about 7 to 10 milliseconds. If the computer, browser, or filter is not fast enough to finish each frame in under 16.7 ms, which is needed for 60 FPS, the app can't keep up. So, the actual FPS drops to a level your system can handle. In short, your computer and browser are working as fast as they can, but processing each frame takes long enough that you can't reach the full 60 FPS.
Well, if you have any questions, pop them in the chat. Everything we do is available on BioniChaos.com, so go check it out as well. You should have lots of questions after doing so. Okay, can we actually make sure it's working better on regardless of the screen size? So in horizontal, in wider screens, that the controllers are probably placed on to the side of the video canvas, and on narrow screen top to bottom. So you know what to do, don't you?
The layout is now responsive. On wide screens, the controls appear to the right of the video, and on narrow screens, they stack below. This should provide a better experience across all device sizes.
100% FPS, yes. Okay, this is much better. Yeah, brightness, contrast, saturation works. Pixel size works. Yes, it's working much better. What? Processing time 40 milliseconds. Why? That's with blur 2.0. Well, the real blur is way worse. But blur 2.0 is still not great. Yeah, Edge works pretty well, so that's usable. It was a 10 milliseconds processing time. Pixelate. Well, trying to overlay like this skeleton image onto it so it looks like an X-ray, but that didn't work. That did not work. Actually have it somewhere in a separate web app. Yes, we can get rid of this a version of the same web application, but it has a separate JavaScript as a worker, as a web worker. We can get rid of that, can we? Oh, well, yeah, the obvious suspects, but those really, yeah, will require more processing. So those will be required, like detecting where your hands and face and eyes are. And we already have 603 lines of code. This one. And format document. Ooh, if I format the document, it's 841. Just applying the, well, it shouldn't matter. I mean, especially now with LLMs, shouldn't matter whatsoever. Shouldn't matter whatsoever. Anyway, we have a bunch of other interesting web applications. Go check them out on the website as well. And don't forget to smash that like button and subscribe as well. Apparently now, every time you say subscribe or something, something should happen. The subscribe button on YouTube should go blinking or something. I don't know, is it blinking for you? Is it blinking? Oh, we have a new Gait simulator. Which is actually, yeah, like well, it says version 3. Reality is, it's more like version 100. Yes, that's what it looks like. Doesn't really fit the screen, does it? There's an ankle flexation, ankle moment. It's Newton per kilogram. Have decrease ankle. Open. That's negative. What does the negative means? Okay. Knee. So bend, open. So that's like extend or something when it goes negative. Negative 5.6. What? And say knee momentum. Okay. Yet the user interface is not great, is it? But the colors, do you like the colors? So this bright green and stuff. You can't actually move the knee. You can click on the charts. The demo should pretty much be the same as play. I can use the scroller as well. So that's probably the best one we've got so far. Let me know if you want to see the previous two. This could have some sounds to it, shouldn't it? I can make the sounds myself. Boom, 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 boom. That's the second version, it's a full thingy. What? Meant to be able to step over. Step over, root boost. And make it higher. Nope. It's getting stuck there. It's getting stuck. Yeah, you can control your stride, this and so forth. It's just weird. No, it can't jump. You would expect it to jump with space or something, but it doesn't. It doesn't jump. So it's our second version, and we had even older one, which is even more ridiculous. Might actually have an expert to look at this stuff. Yes, we have Gait version 2 with a full-fledged thingy where you can control knee rotation, knee lift. Yeah, we did. Yeah, we tried to fix some stuff with it. Obviously, there's some problems. I can't even know how would I go about fixing it if I can't even explain what the problem is. And we have this one as well. This one's probably the most useful one. Can give it to any of those, to one of the big models, tell us what they think, or just leave it as is for a while. What else we've got? Oh, we have a new illusion. A new illusion. Yeah, that one's probably ready to be published. Okay, kind of the title kind of gives away what is it we are looking at. But bottom line. So to see the illusion, yeah, we need a demo mode that would just go probably from number of lines. Number of lines will also set the number of dots there. So it's not actually number of lines, it's the number of dots. So when you go 2, you have this 2 circles moving left to right, and does it look to you like there's a circle motion or not? Well, probably not, because I started with the 1. How about now though? Does this look like circle motion? Well, this looks like very circle motion to me already. But if I'm showing the lines, do you stop seeing the circular motion? Let me know. Well, I cannot do, because, well, now it's clearly that the dots are just moving along up and down those 3 lines. So same happens with, this meant to be 4. It's hard to count, because, yeah. But yeah, it's 4 lines. If you remove the lines, does it look like it's moving in circle motion now? Well, how about now? Well, this is definitely a circle, isn't it? But yeah, you can see they just each one. So if you take that one, follow it along, it's just moving up and down. It's not, there's no circular motion going on. The only thing is the timing. So when you show helper, you can see that green radius is setting where each dot will be touching the outer perimeter. Yes, you can go play around with it yourself. Yes, if you remove the helpers. So interesting enough, I don't know what happens to you. Hey, when I remove the lines and the helpers for this too, does it still look like circular motion, or it does not? Well, what do you see? Because I see them just moving in a line. But apparently some people report still seeing circular motion. And obviously if you do see circular motion or not will depend on what came before. So because if you move it from just 1 to 2, pretty sure you are way less likely to see circular motion. But if you move from 3, which does look like circular motion a lot, to do, maybe you're still seeing the circular motion. So it kind of matters what was shown to you prior. Yeah, so the effect is already pretty strong with 3 dots. And again, those are the lines are back and the helper is back. So in this case, I don't know if you can see it just following the lines, don't you? Yeah, and as per usual, this web application is available to you at bionichaos.com/circmotion. Just pop it the link in the chat or the description of the video. So that was nice and easy. Obviously, optical illusions have a lot of relevance to neuroscience because you can study how in this case, visual system works. You can ask a question, for example, how do you know which part of the visual system actually gets tricked the most? That would be a good question if you wanted to pop something in the comments or the chat. So yeah, let me know what's your most favorite optical illusion. You can try turning it into a simulation. It doesn't always work. Hey, go check out the website. Everything we do is available on BioniChaos.com. Don't forget to provide your feedback. And I'll see you next time. Bye.